Okay, so today I'm focusing on the R2 type questions for this test, the cumulative number 3. And so these are R2s from 2 different chapters, and honestly, even the R2s are a little harder than usual. So let's look at an example of something from R2 land that you should be able to do. You have to be able to answer several questions about just a simple equation like this. Number one, what's its degree? If I were you, I'd write down this problem and then the answers to see if, act like it's a test right now. Would you know what degree this is? Don't say it, write it. And then next question, what's its end behavior? And don't forget there's 2 ends. I can't spell behavior apparently. There's 2 ends. If I were you, I'd always figure out the right end first and then the left end. Next, what's its y-intercept? Next, what's its lead coefficient? I'm going to pause for a second. That's one of many little things you'd need to know to answer R2 type questions. I'll pause while you try that one. Okay, if you didn't have them done by now, you really didn't know it well enough. So I'm going to go, and if you're not ready, that means you need to study this. The degree was 3. It's just the biggest power that you have. Now, if it was written out as a multiply problem, that's the only time when you'd actually do anything to the powers. If I asked you for the degree of the black one, do you get it would be degree 5? Okay, notice there isn't a 5, but you'd have to put them together. Why don't you put anything together on this? Because it's already multiplied out. All right, next is, what is the end behavior? I always say to start on the right. I know it's kind of counterintuitive, but the right comes from this. And that tells me down on the right. And then I just decide if it'll be the same or different. And that, being an odd number, an odd degree, says it's different on the other side. So left would be up. Raise your hand if you had that one right. Be honest, it helps me to target my questions. Okay, yes? If it was even, it would be the same as the right.
Oh, is it down because of the negative?
Yes, the reason it's down right now is because that's negative. So if I change this to an even number like a 4, then it would have stayed the same as that. As in the other side would be, both sides would be down. All right. Next, let's go to y-intercept. The y-intercept is where? Finish that sentence. X equals 0, and you put in a 0 and a 0, and that's all gone, and it's just 7. But I mark it wrong. Why? Why would you mark that wrong? Because you need to write it as a point. What, comma 7? And make sure that that's the y-intercept, so x is 0, right? So 0, comma 7. I'll try to remind you about that, but don't leave just a number for a y-intercept or an x-intercept. Okay, next one, lead coefficient. I scribbled it out, but if I can move that over, I can see the lead, the main one, the one that's got the biggest power, -3. Are there any of these that you want to practice more of? Okay, then next topic. And you can always practice more, by the way, if you want. Here's how. Imagine for a moment that your friend was allowed to give you a copy of the test ahead of time. I know it would feel like cheating. Imagine for a moment it wasn't cheating. I don't know in what world it wouldn't be cheating, but imagine for a moment that somebody could tell you the test ahead of time. Wouldn't it be nice to look through the test and go, yeah, I can do that one, I can do that one. Ooh, I can't do that one. How do you do that one? Well, you got something like that. In the notes that are posted for the last couple days, the review, there's a thing called R2 Extra Practice. Look through that, and if there's any of those, think of it as like, maybe it'll be more motivating to do it. Act like your friend just gave you a sneak copy of the test. And you can go legally, without any guilt, I don't know this and this and this. Well, then you can even look at the key. It's like your smart friend showing you how to do the ones that you don't know how to do. All right, so again, It's legal to do that. Just look on Schoology at the R2 extra practice. Right. And you'll know which ones you need the most help with. All right, next one. This is at 8 and at 3 and at -2. Those are the key spots here. Can you tell me what kind of roots these are? There's words for them, single, double, and triple. And there's other words like bounce, snake, and cut through. Label this picture with every place you see a bounce, every place you see a cut through, everything that's called a snake, anything that's called a triple. And the last is write an equation for it. Now, I know you won't know the stretch factor. The number that's in the front, that's kind of a mystery, but you'll know whether it's positive or negative. And so I'm going to write one that I'm not saying is right, but I'm not saying that's the right answer, but write me an equation kind of like that. That could be the right answer if you happen to know the stretch factor. Okay, I'm going to pause for a second while you cover those topics. Okay, so that's a double, also known as a bounce. That's a single, also known as a cut through. That one, it's got this weird snake shape. I like to think of it as a snake. It acts differently than all the other ones as it touches the axis, and that one's a triple. All right, and what equation could you have? You had one. What do you have?
Plus 2 squared, then x subtract 3, then x subtract 8.
Now, I didn't notice whether you had a positive or negative. Did you on purpose look to see if it should be positive or negative?
Oh, because of where.
Ah, so you may not have noticed it. But now, what do you think it should be, positive or negative?
Positive.
It is positive. So you didn't, but if you don't look, you might by accident not notice. I happen to have this one end going up, but if I had it ending going down, you would have needed a negative. So just watch for that. Okay, question?
Shouldn't it be the opposite because it's 5 if you do them all? Actually, no, because it's x, because it's 6 counting the x subtract.
Yep, this one here. So it's 6. So it's going the same direction, and it's degree 6. So yeah, that's a good example. That's a good answer. Could there have been other answers? Yes, there could be more than one answer for this, but that's a good one. Any other questions? Okay, so many things to talk about. All right, next one. Let's say you got something and it's already all factored out for you, and it looks like this. And they say, what are the real and imaginary roots? If you could do cool kid factoring, the kids that were able to do that last year always got the imaginaries right. I want to pause for a second while you give this a try. All right, so that, if you can do the cool kid factoring, is x plus I root 7 and x minus I root 7. And then this one's still x plus 5. Boring, because that's easy. -5. This one, positive and negative I root 7. If you want another way to get those answers, it's set this equal to 0 and solve. Oh, and I forgot a negative in there. That was a negative, and that's I root 7. And it's plus and minus. So, you know, honestly, that's why this factoring thing, if you can get used to that pattern, it's actually faster. If you just learn that little pattern, it's a lot better than having to show all that red work to get the imaginaries. Okay? All right, if that's your weakness, one of the best things to know is what you don't know. If you know what you don't know, like, oh, I don't know how to do imaginary factoring, well, then that's the thing you should go practice tonight, because that's going to be on there. Yes?
What's the answer?
So the question was, what are the roots? And the answers are, the real root is -5, and the imaginary roots are I root 7 and negative I root 7. And those are the roots, also known as the zeros. That means I can plug in negative 5 into the original, and it'll make it equal 0. And I can also plug in this, and it'll equal 0. They're called the zeros, the roots. Got to move on to the next topic. Yes?
Just about that on the test.
Yep.
We wrote, like, x equals plus or minus. I would say that.
That is acceptable, yes. Why can't you add those yet? They need a common denominator. You're right. So, oh, are we doing the physical representation of a chair thing now? Except in this problem. Okay, anyway, just add them together, get a common denominator, and get one final answer that's a fraction. Hint, the common denominator is 2x. You always just multiply the denominators. There's fancy pants ways to do it with GCFs and stuff, and I'm convinced that it's just as good to just always multiply the denominators. You can always simplify it later. The only time those others are better is if you can, because they can simplify better, but you can always simplify it. Okay, did you multiply this one by 2 over 2 and this one by x over x? Raise your hand if you were doing it right. Okay, awesome. Then you'd have 2 plus x over 2x. And I think that'll all cancel. No, that won't cancel. The bottom part's prepped for canceling because it's factored, but the top isn't factored, and so nothing could cancel. All right, judging by the people staring at that burning holes in the board with your eyes, I think I need to try another one like that. 8 plus 1 over x minus 3. Find a common denominator and add them. First of all, give it a denominator of 1, and then you say, what is a common denominator? Well, multiply the two denominators, so x minus 3. So this one's already got a good common denominator, and this one needs it, so you multiply this one by x minus 3. Could you argue you're multiplying the other one by 1? Sure, go ahead, multiply by 1. See what happens. It stays the same anyway, right? And then, now, if I multiply this out, on the top, this 8 has to get distributed. The most common mistake is in the distribution. 8x minus 24 plus 1, forget that guy, all over x minus 3. 8x minus 23 all over x minus 3. Double checking myself to make sure I didn't screw up. Pretty sure I did that right. Raise your hand if you got the same thing as I did. Okay, awesome. Going for a record on questions, but as long as you're on task, I'm good with it. What? The bottom is the same, and so it stays the same. Yes. I'm going to give you an example. What if I had 1/7 plus 3/7? Is that 4/14? No, it's 4/7. So the bottom stays the same. Okay. Now, this one stumps a lot of people because they're not like ready for it. Here's my answer. What's the domain? Now write the answer. Don't just think it. Write down how you think you'd write that. What are you talking about? I'll give you a reminder what domain is. Domain is really saying this. What can you safely feed this function? And hint, the answer is usually everything except what? Okay? And in this case, it's everything except what? Positive 3. The one thing it can't be is positive 3. Okay. So then, final answer, how would I write that? I personally write it like this. It can't be, that's 3 repeating. I didn't mean that. Minus 3. So then you got to shade it, though. Don't forget to, I'm blaming you, Bjorn. All right. Positive 3 can't be 3. All right. So, again, doesn't feel like this kind of problem, but we can do that. What's the horizontal asymptotes? If I were you, I'd ask Bob. Is it a Bob? Is it a sob? Ooh, yes it is. If it's a sob, then it's y equals a ratio which would be 8 over 1, which is 8. Y equals 8. All right. Does it have a horizontal? No, not horizontal. We just did horizontal. A vertical asymptote. Yes, it does. Those things that are on the bottom, those are verticals. So it's x equals 3 is the vertical asymptote. Okay. Does this have a hole? Does it have an asymptote? Does it really have both? Yes, it does. Where exactly is the hole? What is the horizontal and what is the vertical asymptote? And I think domain is actually, it's not supposed to be hard, but it's actually a tough question for a lot of kids. So I just want to keep hitting you with domain. It's what can you safely feed this function? Okay, so hole. You should have said there was a hole at 0, but if you just say 0, it's wrong. It's 0 comma something. That's one of the hardest parts. 0 comma what? Well, you simplify this and you write down the new answer, which is x plus 5 over x minus 7. No, it doesn't need those parentheses. You can have them or not. And then if I put the 0 in that, I end up realizing it's negative 5/7. That's rough, but yeah, you'll have to have that. How many of you actually had that without me prompting? Okay, nice. Horizontals. Does it have a horizontal? Well, is it a bob, sob, or a bot? Sob. And as long as you cancel exact same things from the top and the bottom, you can do the before or the after. This one or that one, it doesn't matter. It's the same on both, and so it's a ratio of the lead coefficient, so it's y equals 1. Next one, vertical asymptotes. Does this have a vertical? Yeah, it's whatever's on the bottom that wasn't a hole. So it's x equals 7. And the domain, here's the really common mistake. You just freshly said to yourself that it can't be 7. So you'll remember that, and you'll put that it can't be 7. But what also can't it be? 0, because 0 would have canceled and made a hole. So there's two things it can't be. It can be everything except it can't be 0 and 7. I often make that mistake and only put one of the two. I made it the same mistake twice in the same day today. Today I made that mistake twice and forgot that there was two things that were not allowed in the domain. Yes?
Like, domain before you do anything. Like, start with domain and then cancel stuff.
Sure. Yes, actually, that'd be great. If I could force you to do that, where you do the domain before you cancel stuff, that would be smart. All right. Still not done. And we're just talking about R2 stuff. Do you see why I don't feel like you've been ready for the R3s? We're still talking about R2 stuff. I threw in a little bit of R3, but there's been mostly R2 stuff. All right. Next thing I want you to remember, let's say that there's a hole in the equation. And this one has been shifted That spot right there is 1 comma 1. It's a normal parabola, except it's been shifted to the right and up. You get what I mean? It's been moved over and it's been moved up. Okay, then it's got a hole also. And again, it was kind of complicated even before I put this hole in there, but there's a hole at, let's say that's 4. So act like there wasn't a hole. What would the equation have been then? And then include the hole. Pause for a second. We figure out an equation for this one. It's got a hole at 4, and it's a parabola that's been shifted 1 to the right and 1 up. Okay, you should have said this was y equals x squared, except wait, it got moved. It got moved to the right, and it got moved up 1. There's my equation, and then you forgot the hole. Okay, now the kid goes, oh yeah, it's a hole, so I'm going to go put a x minus 4 in here, and I'll put an x minus 4 here. Wrong. Won't work. False. Okay, why? Because that won't cancel the way it is. Now, if I put a parenthesis around all this, then it would cancel and it would work. Because this will cancel off just like I want, and then I'll have my parabola that's been shifted without the hole. So don't forget the parentheses. These right here, I'll make them blue to make them stand out. These, a lot of kids are going to forget, and they're going to lose at minimum 5%. Yes? Yes, you can. There's another way, and that would cancel, and therefore that would be okay. Yes?
We put 1 x subtract 4 on the bottom.
You do not need a 1. Because if you ever cancel something, you're technically supposed to replace it with a 1 when you cancel things. You're really reducing them. Okay. We're still not done. All right, so your only homework was what I told you, where you're going to look over the R2s, see if you can find anything that would have stumped you. All right, last one, though, for today. What is the time? Double checking to make sure. Okay, yeah, we're still fine. My clock is doing really weird things. It holds like 5 seconds and then it... You notice that yet? Holds like 5-7 seconds. And...
Yeah, no,
Are all the school clocks doing that?
they need to fix the,
There's an atomic clock. Oh. There's an atomic clock that this is like set to, but I hear you. That's something that's like you can't set the atomic clock. But these clocks are all somehow linked to each other. They're all on a server apparently. I did not know that. Okay, and obviously the server is down. See what I did there? Okay. All right. So anyway, last one. Yes. X equals 1 is a root. This is usually the beginning of a synthetic question. See if you can do synthetic on this. There. Use synthetic to do division on this problem. Another way to say it is to say factor this using the fact that x equals 1 is a root. But again, focus. Use synthetic. Yes.
Is there any question on the R2 test where we use synthetic on a divide problem like that?
Good question. Essentially, his question is basically, because you can't ask me what's on the test, but the way you should have phrased your question was, will I have to know long division for this test? And the answer is yes. I am not going to promise whether it's on the R2 or the R3, because frankly, I can't remember. But I do know you do have to know long division at some point. But for right now, please do this one with synthetic. One of the benefits of taking the R2s tomorrow and then getting it back the next day is you'll get your R2s back before you have to take the R3 part. See what I mean? Right. If you really bomb the R2 part, you might be like, crap, I really should study for the R3s then. Yes, you're right. I made it simple on myself to think up the problem. But there are problems where you wouldn't have been able to use factor by grouping. And usually what happens there is they have 5 terms. And if they have 5 terms, then you can't factor by grouping, and you'll have to do synthetic. But this one will work at least. Here's your practice of synthetic. One goes like this. 1, -1. 1, -1. Draw the line. Drop it like it's hot. Multiply. Add. Multiply. 0 times anything is 0. Add. Multiply. Oh, wait a minute. Oh, +1. I see. I was like, it's not going to work, but it is. And then when I add them, I get 0, and I wall that off because that's the remainder. And it proved that it worked, but you weren't going to be allowed to just leave that as your work because it doesn't actually have the answer. The proof that this is a root would be that you could factor it. So hopefully you can make this into 2 factors. Everybody try to interpret what you have left as something times something. I think you know what I mean. Just don't forget to do that. Do you know what I mean? Okay, what do you think? X minus 1? X squared plus 1. Awesome. And if some people are going to ask me, I know, do you have to do that one kind of factoring at the end? Only if they ask you what the imaginary roots are. If you wanted to, you are correct. It would look like this. That's a weird plus sign with a dot above it. I dotted my plus sign. And now I can pretty easily see it's got a root at 1, and it's also got a root at I and -I, but they're not real roots. So they would make the equation equal 0, but they aren't real roots. Okay, I think we're about as ready as we're going to be. Your assignment is it's totally individualized. You need to open it. So everybody get it open right now. Find the R2s extra practice. Look through it. If you are the master of all of them, if you're like, I could do it, I could do it, I could do it, I could do it, then you're done. If you find any that you'd be like, gee, don't know what they're talking about, you may want to look at the key for that one. Okay, so that's your only homework is to look through the R2s extra practice and see if there's any that would have stumped you. And that's all I have for the video for today.